I'm also fine. Thank you for asking, Jane Shimoga. So make sure the screen is visible to you and I'm audible. Uh, Give a yes and no in the chat box if the screen is visible to you and I'm audible to you. Okay. Hi, JNV Kolhapur, Sneha, Akshmana Sharma is doing this. Bindu, Harmit Trivedi, JNV, Mukla Shimoga, Likita Navodya, Srinidhi, and Siri. How are you all? I'm also fine, Harmit. Thank you. So is the screen visible to you and I'm audible to you? Let me know in the chat box, everyone. Harmit, is the screen visible to you? Likita? Okay. I welcome you all in this session of mechanical properties of, sorry, it's not the mechanical properties of solid, it's the mechanical properties of fluid. Okay. Let me correct it. So, mechanical properties of fluid we are going to start today, because in the previous session we have done with the mechanical properties of solid. We have analyzed the rod as a form of spring and we have calculated the increment in length of a rod by exerting the principle of spring force. Hmm? So today we are going to elaborate about mechanical properties of fluids. Okay? This is a very important chapter. Now I'll brief you about what we are going to do in the entire chapter. First is pressure inside a fluid. Because whenever we talk about fluids, this term arises here, which is pressure. Okay. So what is the pressure exerted by the fluids on the fluids? We will be discussing that factor here. Then after we will be discussing about the buoyancy and Archimedes principle. You must have seen that some bodies are floating over the water and some will sink in the water. This principle is nothing but the buoyancy and Archimedes principle. Okay, this is because not because of Archimedes or buoyancy, because of the property of water. Okay. That okay, this term we can define as a buoyancy. Okay. Buoyancy is there, but Archimedes has defined it. Okay, discover it. So the third thing is we are going to do is equation of continuity and Bernoulli's equation. Okay, how the energies and pressures is varying. Okay. Then viscosity के बारे में we will deal that when you uh, move your hair in move your hand in air and when you do the same with liquid, you will find some kind of resistance. This is because of the viscosity. Okay, so we will be discussing that factor also, and after that surface tension. So most of you have seen that some of the liquid will wet the surface and some of the liquid will not wetting the surface. Why the uh, raindrops are circular in nature? Why always liquid trying to attain a circular shape? So it is because of the surface tension. We will be elaborating this also, okay, in the upcoming lectures. So now to start with pressure inside a fluid. Okay, so in this thing we are also going to define introduction to fluid and fluid pressure, Pascal's law and hydraulic machine, variation of pressure with depth in fluid, and atmospheric pressure and gauge pressure. So this is also termed as fluid static. If I tell you, this is also termed as fluid static. Okay, fluid static. देखो, we have defined this chapter as fluid mechanics also. Fluid mechanics. Okay, and fluid mechanics contain two parts of the fluid mechanics we have divided into. First is fluid static, and second is fluid dynamics. Fluid dynamics. Okay, so this particular thing is comes under this section of fluid static. Okay, because in this section we will be dealing by assuming that fluid is in rest. Okay, so all the calculation or Pascal's law all over this. Okay, we will be doing it in a fluid static manner. See, here we have fluid. The definition of fluid is that fluid is a substance which can flow even under the small application of force. So this is how we will define fluid. So fluid is nothing but which can flow. ठीक है, फ्लूइड से ही आप ये याद रखेंगे बात, फ्लूइड इज नथिंग बट which can flow. ठीक है, so fluid is nothing but which can flow. ठीक है, fluid is a substance which can flow evenly under the small application of force. So whenever we apply a little bit of force into it, ठीक है, the fluid will displace, and it displaces forever. If you give the slant of it, you can see the example of river here. ठीक है, if it just if we just push it like this, the water will flow continuously. There is no a gap, or there is no need to be apply a large amount of force to displace a fluid. Okay, even you can blow the air is also categorized into fluid, because everything which can flow is defined as fluid. So liquid as well as this gases also defined as fluid. देखो देखो, you can flow air by applying a very little force. There is amount of air is coming out of mind, coming out of the mouth. So this is kind of the definition of fluid. Fluid is a substance which can flow even under the small application of forces. Okay, both liquid and gases are known as fluid. You can take the note of it. Okay, देखो, in this section if you will see, the river is flowing. River flow is because of the change in level of height. Okay, so water will flow from the upper side to the lower side, and that will create a river flow. Okay, river will always flow from the upper side to the lower side. Okay, so this difference in height is the driving force to flow the fluid, to flow the river. Okay, to flow anything we need a driving force, whatever it is, we need this to get a flow. चाहे वो फ्लूइड का हो, चाहे वो चार्ज का हो, चाहे वो इलेक्ट्रिसिटी का हो, किसी भी तरह का कोई भी फ्लो है उसे कराने के लिए वी नीड अ ड्राइविंग फोर्स. ठीक है, either this driving force naturally occur or this driving force we have to apply artificially. Okay, in the case of river flow, जो रिवर हमारे पास है जैसे गंगा है, गोदावरी, so these are not man made rivers. ठीक है, these are nature made. So in these examples if you will see, the river is flowing from upside to the hills to the plain, so it is because of the height difference. Okay, clear? Here you can also see, देखो air is flowing, air is also flowing due to this driving force, and that driving force is the pressure difference. Clear है? देखो now what is pressure actually? Here we have this example. देखो, we are hitting this nail through this hammer, and we are getting this smaller cross section on the other side, and in the second example we get the sharp side on the other side. In which part or in which process of this hitting the nail will easier to get into it, get into the block? So it would be easier in this case. ठीक है, very good, very good. Why it is? Because pressure somehow dependent on the area. ठीक है, very good. JN विषय में होगा more area less pressure, and that's how we will define this fluid. That's how we define this pressure. Pressure is nothing but the normal force per unit area which is acting. So suppose we have a surface like this, and we have applied a force to the surface in on this direction. Let's say this angle is theta. So we can resolve this force into two components, F cos theta and F sin theta. Now the pressure will be exerted only on by this F sin theta force. Okay, and this perpendicular component over the surface is termed as thrust force. F sin theta. The pressure force, always remember, is nothing but the F thrust. F thrust divided by area. Clear? So now you can say more is the area, less is the pressure. And we have seen it in the case of nail. So when the nail is, we have applied the force like this, then it is easier to penetrate nail into this wooden block. Why? Because the area here is very small. Okay? If the area is small, then the pressure on it will increase rapidly. While on the other case, if we revert the direction of the nail and start hitting it to the sharper side, then you will find the here area is very less. Okay? Area is very less. So we have applied an enormous amount of pressure. But here we are talking about the end which is going to penetrate. The area has increased. If area has increased, the pressure will decrease. ठीक है, pressure क्या करेगा? Decrease कर देगा, and that is more tough to penetrate the nail into the wooden block. ठीक है, so it is nothing but the normal force per unit area. Clear? Per unit. So for this example, this is a block. We have applied a force onto this with this area A. So it is normal force upon area. Now, this is the question arises that force is a vector quantity or a scalar quantity. Sorry, pressure is a vector quantity or a scalar quantity. So pressure, always remember, pressure is a scalar quantity. The unit of the pressure is Newton per meter square or Pascal. ठीक है? Dimension formula you can also note it down. Always remember this 1 MPa. All you will find this always written is like this 1 MPa. 1 MPa is nothing but 10 raised to the power 6 Pascal. ठीक है? Clear है? 1 किलो पास्कल is equals to 10 raised to the power 3 Pascal. Got it? ये दो important term है that we use frequently. You can write it down in the notebook. All per meter square. If you take in spite of meter, you will take mm. So it will become 1 into Newton upon 1 meter में how many millimeter we have? 1000 means 10 raised to the power 3 and it is the square of it. Okay, into mm. Clear? So it will become 1 into 10 raised to the power minus 6 Newton per mm square. ठीक है? Clear हो गया? You can also do this in this way. So you can also say if you multiply 1 Newton per mm square is equals to 10 raised to the power 6 Newton per meter square. Can we say this? Because 1 Newton per mm square is equals to this. So when we take up this on the other side, it will become like, let me do it here. 1 Newton per meter square, we have converted into 1 into 10 raised to the power minus 6 Newton per mm square. Okay. Can we do, if you take up this value here, it will become 10 raised to the power 6 Newton per meter square is equals to 1 into 10 raised to the power 1 Newton per meter mm square. So directly 1 mm square, 1 Newton per mm square, if it is given, it is directly equals to 1 MPa, megapascal. Okay. You can make a note of it. Clear? Now, this is the another demonstration. Importance of pressure you can see by cutting the vegetable. देखो कितना इजीली है ब्रोकली को कट करना, कैरेट को कट करना. ये देखो कितनी तेजी से ये कट कर रहा. ठीक है. नाउ दिस इज द रेल. ठीक है. तो सभी ने देखे होंगे ना रेलवे ट्रैक्स पे, जिनके ऊपर रेल बिछी होती है. इस जो लाइन होती है ना, इसे ही रेल बोलते हैं. रेल वो नहीं होती जो इसके ऊपर जा रही होती है, उसे ट्रेन बोलते हैं. ठीक है. दिस इज द रेल एक्चुअली. क्लियर हुआ? तो हम ये ज्यादा सरफेस एरिया इसीलिए पुट करते हैं, टायर से इससे पड़ेगा ना, वो प्रेशर इस बड़े एरिया पे डिस्ट्रीब्यूटेड हो, और जितना एरिया बड़ा होगा, एज द एरिया इंक्रीजेस प्रेशर डिक्रीजेस. तो प्रेशर को डिक्रीज करने के लिए वी यूज द स्लीपर अंडर द रेलवे ट्रैक. गॉट इट? So always remember it. Now ready for the challenge. Why camel can easily walk in desert but we cannot? Why? It's a game of pressure now. You can see this is our feet, a human feet is there, and this is the size of a camel feet. So a camel which is much heavier than can easily walk on sand, because camel का जो foot area होता है, the foot area is larger than the foot area of a man or a human. So in that way, the pressure that we exert is, let's say, F upon E, and the pressure that a camel exerts is also F upon E. But this area has increased its value, so the pressure will decrease. And here, less area, more pressure. So that is why when we walk over the sand, we apply more pressure to the sand. That is why we get into it. ठीक है. बट कैमल का जो फुट का सरफेस एरिया वो ज्यादा होता है, इसलिए वो Yeah, it has larger pad fit. Very good, Harmit. I think you all got it. If anyone has any kind of doubt, you can ask. Now we will talk about density. Because to calculate the pressure, we need a density. That is why we need to define it. And moreover, you were well aware about it. What is density in your previous classes? Density is nothing but the mass per unit volume. How much mass we can contain in a volume, that is the actual meaning of density. It is given by MYV. So this rho represents here what? Density. M represents here mass and V represents the volume. Okay. This is also a scalar quantity. Unit is already kilogram per meter cube and dimension you can say ml minus 3. Now the fun fact here is, let's say if I'm saying that rho is nothing but 1 kilogram per meter cube, which means in a cube of, if you draw a cube which has side length 1 meter, this side will be also 1 meter and this side is also 1 meter. So what is the volume of this cube? Volume of this cube is 1 meter cube. Okay, clear? Now what does rho means here? It's 1 kilogram of meter cube, which means we can put 1 kilogram mass into the cube of 1 meter volume. Okay, suppose the density, for the example, density of water is 1000 kilogram per meter cube. So this example may, what you need to understand, that if there is a cube, if there is a cube if there is a cube of side length 1 meter, तो ये भी कितना होगा 1 और ये भी कितना होगा 1. ठीक है, so volume will become ultimately 1 meter cube, है ना? So what does this mean? Density of water 1000 kilogram per meter cube. इसका क्या मतलब हुआ? If you have a cube of 1 meter cube volume, then you can pour 1000 kilogram of water into it. Okay, then you can pour 1000 kilogram water into it. Clear? अब आपको समझ में आया what does it mean? ठीक है, so आप यहीं से बता सकते हो, if a material has 500 kilogram per meter cube of volume and water has 1000 kilogram per meter cube of volume, which means in a cube of 1 meter cube, this material we can pour only 500 kg, but water we can pour it 1000 kilogram, which means that we can pack more of the mass of the water, which means कि water is much denser than this liquid. Okay, water is much denser than this liquid. Clear हुआ? Or whatever the substance is. For example, let's just try to solve this question. If the area of wall of a dam, if area of a wall of a dam is 20 meter square and a normal force of 1500 Newton is applied by the water on it, then calculate the pressure applied by the water on the wall. तो very simple question है. मेरे पास एक डैम है, and somebody has answered also 75 Pascal. Okay, very good. The water is applying pressure into it. Okay, now the pressure force is exerted on the this face perpendicularly. Okay, or on the this face. So if you see on the top view, you will find the force which is acting is always perpendicular. ठीक है. The area of the wall is 20 meter per square, 20 meter square. Okay. And normal force which is acting is 1500 Newton. So pressure here will become force upon area, which is 1500 upon 20 meter square. It is coming out to be 75 Newton per meter square. And we know that Newton per meter square is written as Pascal. Okay. Very good. Another one has also answered Hermit. Yeah, as expected, Hermit and Shimoga. Very good. Clear? Now, the important law and the beginning of fluid mechanics or the fluid static is by Pascal's law and hydraulic machine. Okay. Now, one more thing I want to elaborate it here, which is about relative density. Relative density. So relative density we represents by rho r. Okay. And it is nothing but density of material, rho of any material with respect to density of a reference material, which is water in case of liquid. Okay. And rho r is equals to density of material, density of air, okay, in case of gas. ठीक है. क्लियर हुआ. अब देखो यहां से आप क्या कह सकते हो, अगर कोई भी आपके पास एक एलिमेंट है, कोई भी मटेरियल है आपके पास, एंड सपोज द डेंसिटी, यू डू नॉट नो द डेंसिटी बट यू नो द रिलेटिव डेंसिटी ऑफ इट. ठीक है. फॉर एग्जांपल लेट्स से द रिलेटिव डेंसिटी ऑफ एनी मटेरियल इज 2. It means that this material, because relative, by this expression you can say, by equation 1 you can say density of material is nothing but relative density of material multiplied by the density of water. So by this expression you can say if rho of relative density is given as 2, you can say that this particular material is 2 times heavier than water. So ultimately it will going to sink in the water. If something is heavy than water, the water cannot have the force to lift it up, okay, to make it float. So it will sink. So, and suppose this is the case of sink. I'll describe it when we will going to study about Archimedes principle. We will be dealing it in a elaborative. But if rho r is 1/2, 1/2 का मतलब क्या होगा कि water से half. Relative density is half of the density of water. If half is the density of water is there, we can say that this particular liquid is much less denser than water. इससे क्या फर्क पड़ेगा कि water has the capacity to lift that object because it's not much heavy than water. ठीक है. So in this case the liquid will float. Now clear है. किसी को कोई डाउट है इस पे relative density? Any kind of doubt in this? Yes and no? Any kind of doubt, guys? Okay. Okay, Bindu, very good. Chali. Next point, which is Pascal's law. Pascal's law and hydraulic machine. So firstly, we will understand what is Pascal's law. Okay. So what is the general idea of pressure inside a liquid? Inside the liquid, we only talk about it. Okay. So we have the basic idea. Suppose we have a vessel here and we have pour liquid into it and make a little bit of holes of same dimension at 3 different segments of it. what we will seeing it that this particular stream of water covering more range. ठीक है, this one, ठीक है, and this is R2. So ultimately we'll see here this R is greater than R2 is R1 and greater than R2. So from here we will having an idea that more is the depth, more is there something which is pushing the water further, and that something is nothing but the water. एंड देखो इसका कितना क्लियर इंडिकेशन है कि डेप्थ बढ़ने पे प्रेशर बढ़ेगा. इस पॉइंट पे अगर आप हो एट द टॉप ऑफ द लिक्विड, देर इज नथिंग टू कंप्रेस यू, देर इज नथिंग टू कंप्रेस यू, बट सपोज यू आर हियर एट दिस. So this much amount of water, the weight of this much amount of water is trying to push you down, trying to push you down ना. So अब अगर हमारे पास let's say यहाँ पे कोई पॉइंट है, एट दिस पॉइंट वी आर हैविंग, सो इन पॉइंट को पुश करने के लिए दैट मच अमाउंट ऑफ वाटर वी है, that much amount of water we have. So as we are moving down, the amount of water which is upside of Earth, the amount of water which is present upper side is increasing. So if the weight force is increasing, ultimately the pressure will going to increase now, because pressure is nothing but force perpendicular divided by area. And this liquid segment having weight W or having mass M, applying a force mg, this segment has weight, let's say m dash g. Since m dash is greater than m, so we can say that m dash g is also greater than m g. More force, which means more pressure. ठीक है, because as we move inside to the liquid, the weight of the liquid contained on the upper side of it is increased. So that is why as we move in more depth, the amount of pressure feel by us is increased, will increase. ठीक है, liquid pressure is the increase in pressure at increasing depth in a liquid. ठीक है, तो आपको समझ में आया होगा what, because why does this force is increasing or this pressure is increasing, because of the mass of the pressure, mass of the liquid is also increasing, and in result of that weight force will increase. Or force is nothing but the weight force of the liquid because it is acting perpendicularly per unit area. So that is why the pressure is increasing, having more pressure. So this pressure increases because the liquid at the lower depths has to support all of the water. ठीक है ना, चलो, I think you have get the idea about it. But gases में क्या होता है देखो, in case of gases, if we about tell you about this pressure forces, so आपने अगर इतना सा कंटेनर ले लिया तो पूरा गैस इसी में ही भर जाएगा, इतना कंटेनर ले लिया तो भी सारा गैस इसमें आ जाएगा, बिकॉज गैस हैज नो वॉल्यूम. ठीक है, फिक्स्ड मास बट नो फिक्स वॉल्यूम. क्लियर, इसलिए गैस के केस में दिस इज नॉट एप्लीकेबल. नाउ Pascal's law is given by the French scientist Blaise Pascal. What does this say? ये important है. A change in pressure at any point in a confined incompressible fluid. Change in pressure, incompressible fluid at rest is transmitted undiminished to all points in the fluid. Which means if we have applied a force to a liquid and that liquid is uncompressible and it is not moving also, then the force or the pressure we have exerted will be equally distributed to the entire liquid. ठीक है, If you push it from here, it will have the effect on the other side. So suppose this is the let's say this is a container we have, and in which the liquid is being filled. Now if you have a stopper like this, ठीक है, so that you can press it down. So जैसे ही आप इसे प्रेशर, यहाँ आपने तो प्रेशर सिर्फ इस सेगमेंट पे लगाया, और कंडीशन भी फुलफिल हो रही है कि ये जो लिक्विड हमने लिया है दिस इज इनकम्प्रेसिबल और दिस फ्लूइड इज इनकम्प्रेसिबल. ओके. So the change in pressure by the if I apply it downward, तो जो प्रेशर मैंने इस पे लगाया it will distribute it to all the parts of the liquid undiminished. It mean it will not loss. ठीक है. Now देखो for this example, अब यहाँ पे देखो, this is the bottle is filled with liquid and that is non compressible. The first statement is this. तो हमारे पास एक बोतल है which is filled with the liquid which is non compressible. जो क्या है, non compressible है. Non compressible which cannot be compressed. The second thing we have done here, a 10 Newton force is applied to a stopper with an area of 1 square meter. तो इस stopper का एरिया कितना है, 1 square meter है, and we have applied 10 Newton force. So total pressure we have applied is what? Force upon area. 10 Newton upon 1 meter square is equals to 10 Pascal. So 10 Pascal is the force that we have, pressure is that we have applied. Now ये जो 10 प्रेशर यहाँ पे क्रिएट हुआ, ठीक है, लेट मी चेंज द कलर. ये जो प्रेशर यहाँ पे क्रिएट हुआ, इट विल डिस्ट्रीब्यूटेड टू ईच एंड एवरी सेगमेंट ऑफ द लिक्विड. तो ये यहाँ पे भी लगेगा, फिर यहाँ पे भी, यहाँ पे भी, ईच एंड एवरी पॉइंट अकॉर्डिंग टू पास्कल्स. until and unless this fluid is in rest and this fluid is incompressible. क्योंकि अगर ये compressible हुआ तो ये compress हो जाएगा, तो मेरा जो फोर्स है उससे कुछ वर्क हो जाएगा यहाँ पे. ठीक है. तो ये इक्वली डिस्ट्रीब्यूटेड नहीं होगा बिकॉज दैट पार्ट ऑफ द लिक्विड विल बी कंप्रेस्ड. अब जैसे मेरे पास ये क्या बोलते हैं, पॉलिथीन. ठीक है, ये मेरे पास एक पॉलिथीन का बोल है, सबको दिख रहा है. अगर मैं इस पे प्रेशर लगाऊं तो ये तो पिचक गया, इट इज इन कंप्रेस स्टेट. ठीक है. बट अगर इसी की जगह करने की कोशिश करूं, क्या मैं उसे दबा सकता हूँ? कैन आई कंप्रेस दैट वाटर? नो, बिकॉज वाटर इज इनकम्प्रेसिबल. ठीक है. इसलिए जब मैंने इसे दबाया तो मेरा जो फोर्स था वो इक्वली डिस्ट्रीब्यूट नहीं हुआ, वो उसी सेगमेंट पे लगा जिस सेगमेंट को मैं दबा रहा हूँ. क्लियर. बट यहाँ पे इफ यू विल सी, द फोर्स or the pressure will distributed all over the entire surface. Clear. Which results in 10 Newton of force on every square meter of the container. So agar the bottom area is what, if the bottom has an area of 2 meter square and each square meter is pushed by 10 Newton, then the entire bottom will receive the 20 Newton push. तो देखो सेम फोर्स है, फोर्स हमने सिर्फ कितना लगाया, कितना फोर्स लगाया, सिर्फ 10 न्यूटन का फोर्स लगाया. बट इफ द सरफेस एरिया हैज इंक्रीज्ड हियर, ठीक है, बट प्रेशर इज रिमेन टू बी कांस्टेंट, तो उस केस में फोर्स की वैल्यू कितनी होगी? अब देखो मेरा प्रेशर कितना आया था, 10 पास्कल. तो प्रेशर जो यहाँ पे है लेट्स से P1 और प्रेशर जो बॉटम पे है P2, दोनों के दोनों क्या होने चाहिए, सेम अकॉर्डिंग टू द स्टेटमेंट ऑफ पास्कल. चलो, सो P1 इज इक्वल टू P2. अब देखो P1 की वैल्यू है 10 पास्कल, P2 will be force upon area. Now force we do not know, area we know, area is 2 meter square, so this A will replace by 2 meter square. Force will become 20 Newton. Got it? Seeing the magic here. So per unit square पे if you will see, per unit square पे if you will see, 10 Newton force is applied, but the total force on the surface area is 20 Newton. Clear? and this is because of equal distribution of pressure. One more important statement in Pascal's law, that is pressure exerted at a point is the same in all direction if the fluid is in rest. ठीक है? So Pascal's also said that pressure exerted at a point is the same in all direction in a fluid is at rest. ठीक है, तो अगर ये कोई पॉइंट है यहाँ पे अगर मैंने प्रेशर, तो वो इक्वल डायरेक्शन में अप्लाई होगा, ईच एंड एवरी डायरेक्शन. ठीक है, ये कोई पॉइंट है, तो यहाँ पे जो प्रेशर होगा, सपोज दिस पॉइंट इज इनसाइड अ लिक्विड, तो ये जो लिक्विड का वेट जो फोर्स लगा रहा था ना, दैट वी आर सीइंग हियर is equally distributed and acting in all the direction. That is why we cannot consider pressure as a vector quantity. क्योंकि अगर वेक्टर क्वांटिटी है तो उसे तो एक डायरेक्शन में होना पड़ेगा, बट इट इज इन ऑल द एवरी डायरेक्शन. क्लियर? Now we will be having this expression of pressure at a depth h. So here we have contained, or we have considered a fluid element on this triangular shape. This is to show you that fluid is, जो फ्लूइड प्रेशर लग रहा है ना, वो सेम है हर डायरेक्शन में. ठीक है, कोई भी डायरेक्शन कंसिडर करोगे, द फ्लूइड प्रेशर एक्सर्टेड ऑन डीएफ सेगमेंट, एबी सेगमेंट और बीसी सेगमेंट इज सेम. ठीक है, तो ये फ्लूइड एलिमेंट कौन है? ए बी सी डी ई एफ, ए बी सी डी ई एफ. दिस इज अ काइंड ऑफ राइट एंगल ट्राइंगल. ठीक है, नाउ दीज आर द फोर्सेस that is applied because of the pressure. Let's say the force applied on this AB surface is FC, force applied on this BC surface is FA, and force applied on this hypotenuse surface. ठीक है, now what we will do, we will resolve this component of FB into two component. If this angle is theta, which is mentioned here, so this force will be resolved into two component, FB sin theta and FB cos theta. ठीक है, क्लियर? ये देखो ऐसे रिजोल्व किया, ये मेरा फोर्स है, ये एंगल थीटा है, तो यहाँ ये दो एक्सिस बनाई मैंने, ये दो, अगर ये एंगल थीटा है तो ये एंगल कितना होगा? 90 माइनस थीटा, बिकॉज दिस एंगल विल बिकम 90. इफ दिस एंगल इज 90 माइनस थीटा, तो दिस एंगल वुड बिकम थीटा, बिकॉज अल्टीमेटली दिस इज परपेंडिकुलर टू दिस. तो इफ इज दिस, अब मैं सब कुछ रिमूव करूँ, अगर if this is, let's say, force B and it is acting in this direction, this angle is theta, just resolve into two component, so this will become FB cos theta and this horizontal component will become FB sin theta. ठीक है, same thing we have written here. ठीक है, now what we can do, अब देखो फ्लूइड तो रेस्ट में है, तो सारे के सारे एलिमेंट पे जितना भी फोर्स लग रहा है वो भी क्या होना चाहिए? जीरो होना चाहिए, नेट फोर्स, बिकॉज फ्लूइड इज नॉट मूविंग एनीवेयर. So the force that is it is experiencing should be equal to each other. Now net horizontal force, we will divide the force into two segment, horizontal forces and vertical force. So horizontal force must be equal to the vertical forces because there is the fluid is not moving anywhere. तो अगर फ्लूइड मूव नहीं कर रहा है तो जीरो होना चाहिए. तो FC will be equated as, देखो FC is equated as FB sin theta and FB cos theta is equated as F here. ठीक है, अब देखो ए बी ए सी और ए बी ए सी और ए क्या है? सरफेस एरिया ऑफ ए इज द सरफेस एरिया ऑन विच एफ ए फोर्स इज अप्लाइड, ए सी इज द सरफेस एरिया ऑन विच एफ सी फोर्स इज अप्लाइड, एंड ए बी इज दैट सरफेस एरिया इन विच एफ बी फोर्स इज बीइंग अप्लाइड. नाउ व्हाट इज प्रेशर देन? अब देखो ए बी को भी मैंने दो डायरेक्शन में रिजोल्व कर लिया, ए बी को भी मैं दो डायरेक्शन में रिजोल्व करूंगा, तो वर्टिकल कंपोनेंट इज ए सी इटसेल्फ एंड हॉरिजॉन्टल कंपोनेंट इज ए इटसेल्फ. but I can write that AB sin theta, which is vertical, equals to AC, and AB cos theta, which is horizontal, equals to A. Now, if you do this, FC by AC, calculate the pressure on surface ADBE. इस पे कैलकुलेट करो प्रेशर, तो प्रेशर वुड बी इक्वल्स टू फोर्स अपॉन एरिया। फोर्स कितना है FC, एरिया कितना है AC, AC क्या है AB साइन थीटा, ठीक है। नाउ फोर्स ऑन दिस सरफेस ADCF इज इक्वल्स टू प्रेशर इज इक्वल्स टू FB अपॉन, FB अपॉन क्या लिख सकता हूँ, टेल मी, FB अपॉन AB। FC को क्या लिख सकता हूँ, यहां से देखो, FC इज ऑल्सो इक्वल्स टू FB साइन थीटा, ये कैंसिल हुआ। तो प्रेशर ऑन ADABF यानी इस वाली सरफेस पे कितना आया, FB अपॉन AB। प्रेशर ऑन दिस सरफेस, ये जो इंक्लाइंड सरफेस है, कितना आया, FB अपॉन AB। और अगर हॉरिजॉन्टल इस वाली सरफेस पे भी निकालोगे ना, तो प्रेशर इज कमिंग आउट एज FA अपॉन AA। और AA को क्या लिख सकता हूँ, AB cos थीटा। पुट द वैल्यू ऑफ A which is FB cos theta, ये कैंसिल, FB अपॉन A। तो we can say that FC upon AC is equals to FB upon FA, AB, FA upon AA। इसका क्या मतलब हुआ, इट मीन्स दिस FB upon AC is nothing but the pressure applied on दिस सरफेस, दिस इंक्लाइंड सरफेस। तो जो इस सरफेस पे जो प्रेशर है, वो इस सरफेस के प्रेशर और ये सरफेस का प्रेशर तीनों क्या है, इक्वल है। So it is also proving our term that if a fluid is incompressible as is in rest, then the force applied or the pressure on that particular liquid at each and every point is equal, ठीक है, in every direction। क्लियर हुआ। और यही क्या है, पास्कल से। अब देखो यहाँ पे, think about the pressure at the bottom of the vessel if vessel ABC contain different amount of liquid but height of the liquid is same। ये ऑर्थोडॉक्स है एक। अब आप कहोगे कि इसमें तो ज्यादा लिक्विड दिख रहा है, तो ये तो ज्यादा वेट फोर्स अप्लाई करेगा, सो इट हैज मोर प्रेशर एट द बॉटम। लेकिन अगर बॉटम का पॉइंट सेम है, मतलब सेम पॉइंट पे आप कैलकुलेट कर लो, और लेट्स से नॉट इनसाइड द लिक्विड, यहाँ पे ये पॉइंट यहाँ है, इसी लाइन को मैंने आगे बढ़ा दिया इस पॉइंट पे, इस पॉइंट तो इनका हॉरिजॉन्टल, इनका जो वर्टिकल लेवल है वो सेम है। इसमें क्या होगा, अब वो हम डिराइव करते हैं, ठीक है। इस केस में भी अगर आप देखो, इन द प्रीवियस केस ऑल्सो, प्रेशर क्या है यहाँ पे, प्रेशर क्या होगा, वही तो निकालना है ना, प्रेशर कितना होगा। अगर आप थियोरेटिकली जाओ, तो यू विल सी दैट फोर्स प्रेशर इज नथिंग बट फोर्स अपॉन एरिया। सो एरिया, यू विल सी दैट एरिया तो इसका ज्यादा लग रहा है यहाँ पे, तो इस पे क्या होगा, प्रेशर कम होगा, प्रेशर एट बी इज लेस, pressure at B is A is more, and pressure on C is in between. So you will find out that pressure of A is greater than pressure of C is greater than pressure of B, ठीक है। क्लियर है, बट इट इज नॉट लाइक दैट, दिस इज ऑल्सो अ पैराडॉक्स, ठीक है, ये अपने आप में ही एक पैराडॉक्स है। चलो एक छोटा सा डेरिवेशन भी कर ही लेते हैं। पहले हाइड्रोलिक मशीन के बारे में देखेंगे। हाइड्रोलिक मशीन क्या होती है? विच वर्क्स ऑन द प्रिंसिपल ऑफ पास्कल्स लॉ। ठीक है, प्रिंसिपल ऑफ पास्कल्स लॉ। और ये हाइड्रोलिक है, विच मीन्स द वर्किंग सब्सटेंस इन दिस मशीन्स आर लिक्विड। ठीक है, और मेनली वाटर्स। So this is hydraulic press. I think one of you have seen. This is hydraulic jack or lift that we use to lift up the vehicle when the tire got punctured or something we have to fix into the water, into the vehicle itself. And this is the hydraulic brake. ये तो सभी ने देखे होंगे, जिन्हें हम डिस्क ब्रेक भी बोलते हैं। ठीक है। Now what is the concept here? If we will see, यहाँ मैंने फोर्स फोर्स लगाया। इस फोर्स से जो यहाँ पे प्रेशर क्रिएट हुआ होगा, मैंने फोर्स लगाया, ये पर्टिकुलर एरिया। तो यहाँ पे प्रेशर इज नथिंग बट फोर्स अपॉन एरिया। अब ये एरिया अलग है, एफ अपॉन ए वन, लेट्स से एफ वन अपॉन ए वन। बट अकॉर्डिंग टू पास्कल्स लॉ दिस लिक्विड इज इन रेस्ट। सो ये जो प्रेशर है ये इक्वली डिस्ट्रीब्यूट हो जाएगा। एंड सो यहाँ भी जो प्रेशर बनेगा दैट वुड ऑल्सो सेम एज दिस, एफ टू अपॉन ए टू। वी कैन से this P1, let's say this is P1 and P2, but according to Pascal's law, P1 is equals to P2, F1 upon A1 is equals to F2 upon A2. ठीक है, clear? So from here you can say F1 is equals to F1 upon F2 is equals to A1 upon A2। ठीक है, अब देखो A1 ज्यादा है या A2? ये क्या है? A1 है। और ये क्या है? A2। A2 ग्रेटर है देन A1। तो ये वैल्यू एंटायरली, ये वैल्यू क्या होगी? लेस देन वन हो, लेस देन वन हो गई ना। A1 इज ग्रेटर देन, सॉरी, A1 इज लेस देन A2। तो A1 इज लेस देन A2, A2 इज मोर देन A1, तो ये वैल्यू लेस देन वन। वी कैन से दैट F1 by F2 is less than 1. Similarly, we can say F1 is equals to is less than F2, which means यहाँ पे जो फोर्स लगा और यहाँ पे जो फोर्स लगा दोनों में अंतर है। यहाँ जो फोर्स लगेगा वो डेफिनेटली ज्यादा होगा देन दिस फोर्स। एंड दैट इज वाई बाय द एप्लीकेशन ऑफ, देखो कितना सा सरफेस एरिया, और इसकी मदद से हम इतने बड़े व्हीकल को उठा सकते हैं। इट इज जस्ट बिकॉज ऑफ द पास्कल्स लॉ। ठीक है, तो हाइड्रोलिक मशीन वही है, आप छोटा सा इनपुट दोगे, वहां पे बहुत बड़ा एरिया आपको एक बहुत बड़ा आउटपुट मिलेगा इन टर्म्स ऑफ फोर्स। पास्कल्स लॉ हमने लगाया तो 10 टाइम्स। तो ये मैंने आपको पहले ही बता दिया था कि इस तरह से फोर्स प्रेशर को मैं एज ए वेक्टर क्वांटिटी क्यों नहीं लिखता हूँ, क्योंकि इट इज नॉट यूनिडायरेक्शनल, इट इज ओमनी डायरेक्शनल, सभी डायरेक्शन में। ठीक है, चलो, ओके। नाउ if anyone has any kind of doubt you can ask, otherwise I have launched a poll, so please do mark your attendance in the poll and participate in the poll guys। ठीक है, and mark each and every question, clear? Please do participate in the poll so that I can mark your attendance. Till then, if anyone has any kind of doubt you can ask, otherwise the lecture is being over. Thank you so much for being attentive and being responsive in the lecture. Bye bye, take care.